Good morning, our wonderful students. How are you doing? How have you been coping with the online class or online classes? Okay, I hope you are finding it very interesting. I welcome you especially to this particular edition of the online class. Right about now, what you have is basic technology, and that is for JSS 2. Basic technology. Oh, sorry, basic technology for JSS 1. Okay, and your topic is basic electricity 1. Your subtopic is circuit components. I remember your lovely teacher, Mr. Samson. Remember that last week we treated this basic electricity 1. Okay, in that last week edition, we looked at current. What is current? Say that it is the movement or the flow of electron from one point of a conductor material to the other. And say, what is electron? Electron is a negatively charged particle of an atom. Okay, and we also looked at an atom as the basic functional unit of an element or a material. Okay, then we also looked at the different types of current we have. We have direct current and alternating current. Direct current is a current that flows in one direction only, while alternating current is one that flows in two directions. Okay, then the sources of direct current are primarily your battery cells, while generator and generating stations are the sources of alternating current. But today we'll be looking at another dimension of the basic electricity 1. Remember that same last week we looked at electric circuit. Okay, we defined it as the arranged pathway for electric currents to flow. So pathway, electric circuit provides a pathway for electric currents to flow. So in electric circuits, there are many components that enables electric current to move round about it. And today we are going to look at those components, and we're going to look at those components. We'll take them one by one and discuss them. We say that electric circuit is a complete part of electric flow with the arrangement of electronic components that allow electric currents to pass through them. So it means that in electric circuits, all the components there are conductors. They allow currents to pass through them. An electric circuit is a part in which electrons from a voltage or current source flow. Okay, a voltage source or a current source flow. Okay, then we'll say that in electric circuits there are many fixtures and components. So in a circuit there are many components, there are many materials there that make it function properly. But we will discuss basically 5 important ones. So we just pick these 5 important ones based on your level. As you continue to grow up in your academic pursuits, you are going to encounter more of them. Okay, these 5 important ones are the source of electromotive force, which we call EMF, the source of electromotive force, resistors, capacitors, inductors, and switches. These are what we are going to focus on in this electronic components, or yes, circuit components. Now let's start with the source of electromotive force. What does it mean? That's the number 1. Electromotive force is known as electron moving force. In a simpler term, electromotive force is known as electron moving force. The force that moves electron. Okay, the force that drives electron. It is vital part of of the circuit, as other components cannot function without it. So this one is the life wire of electric circuit. If this one is not there, your other components in the electric circuit will be lying low. They will be lying lifeless, inactive. Okay, in fact, this is the only active component of the electric circuit, as others are passive. Okay, now we say in electromagnetism and electronics, electromotive force, that is EMF, denoted by the letter E and is measured in volts, is the electrical action produced by a non-electrical source. Let me explain this thing now. What we are trying to say is that electromotive force, is the symbol is E, letter E, okay, and it is measured in volts. EMF is measured in volts. So in other words, it is voltage. In other words, it is voltage. It is the driving force of electrons. Okay, it is the electrical action produced by a non-electrical source. I'm going to explain this statement. Is electrical action that is produced by a non-electrical source. Let's see the next slide and see what is there. Now, devices as transducers provide an EMF by converting other forms of energy into electrical energy. That's what we mean by this, our last statement here. Okay, we'll say that electromotive force is the electrical action produced by what? A non-electrical source. What are those non-electrical sources? That is what we saw here now. Okay, device which is known as transducers is used to convert other form of energy which are not electrical energy into electrical energy. Okay, the other forms of energy which we have, such as batteries, which convert chemical energy to electrical energy. Batteries convert chemical, because what is inside your batteries are chemicals. The transducers convert the chemical energy in your batteries to electrical energy. Then in your generators, which are motion, what is in your generator are mechanical energies. Transducers also convert this mechanical energy into electrical energy. Sometimes an analogy to water pressure is used to describe electromotive force. The force in this case is not used to mean force of interaction between bodies, like in the case of Newton, okay, pressure over the area. No, that's not what we're talking about. All right. Okay, now we want to see the different sources of electromotive force. In this our diagram, as you are seeing here now, we have different sources. The first one by my left, the upper one by my left, is windmill, which generates electricity through wind. Those windmill there, as you're seeing it there, once wind is blowing, as long as wind is blowing, it is rotating, and as it is rotating, it is turning a turbine, which generates electricity. I'm not going to bore you with the detailed explanation. Below it is the battery, which has chemical in them. The chemical energy is converted to electrical energy through a transducer. Now, the upper one by the left is hydropower. That is power from water. Hydro is water. Now, this hydropower is converted to electricity, or used to generate electricity using turbine. You are going to see more of this in your JSS2. Then the below, the down one by my right hand side, is a solar panel, which converts the solar energy into electrical energy. These are the sources of what? EMF, electromotive force. Sources of electromotive force. In other words, they are the sources of electricity. Okay, now this is the symbol of EMF. E, it is denoted as E. So when you see this is the symbol here by my left hand side down, you will see E there. You see a symbol of plus and minus. That sign shows a sign of EMF. It can be battery or any other source, okay, but in a circuit like this we usually call it battery. Okay, now E is, I'll not bore you with that formula for now. I'm going to explain it more in our next class, okay, but just know that E is equals to IR plus IR. Now what do we mean by IR? And I is current, you can see it in the circuit there. Then R is the resistor, you will see it here. Then this I again is for the current, then small r is for this small resistor down here. Okay, the same thing happened here. E is for EMF. Take that for now. Okay, now we're going to look at the basic component of electric circuit 2, which is the resistor. Okay, we said that this is another circuit component which converts electrical energy to heat energy. Okay, it checkmates the flow of voltage from one component to the other, or the voltage entering the entire circuit. Now the function of resistor is to convert parts of electric current or voltage into heat energy. Now why does it do that? It do that in order to regulate or checkmate the amount of current that is entering into a particular component, or even in the entire circuit, because it allow a particular amount of current to pass through it. So once a resistor is introduced, the amount of current that will pass through that resistor depends on the capacity of that resistor. Are you getting what we're saying here now? Okay, so a resistor is a passive two-terminal electric component that implements electrical resistance as a circuit element. Now, passive means that it is not active. It just receives current. It just receives, its own action is to receive electric surge, voltage into it and do work with it. What does it do? It regulates. It either convert parts of it to heat and dissipate it to the surrounding, then allowing specific amounts of current to pass through it. That's what it means by that. Okay, so in electric circuits, the resistors are used to reduce current flow, adjust signal levels, divide voltage, and bias active elements, and even terminate transmission lines, among other uses. So I have mentioned about 4 uses of a resistor here. 1, reduce current flow, adjust signal levels, to divide voltage, bias active elements, terminate transmission lines, and many other ones. High power transistor can dissipate many watts of electric power as heat. Okay, may be used as part of motor control in power distribution system, or as test board for generators. Okay, now we have majorly 2 types of resistors. We have fixed resistors and we have the variable resistors. In the case of fixed resistors, have resistance that only change slightly with the temperature, time, or operating voltage. So in the case of fixed resistor, it changes just very little. Okay, when there is a change in temperature, maybe time, and the operating system. Then we have the variable resistor. This one can be used to adjust. So variable can be used to adjust the circuit elements, such as volume controls or lamp dimmers. The shining brightness of a lamp, the level of volume in your electronics, your home theater and sound systems. Okay, or as sensing devices for heat or light, humidity, force, or other chemical activities. So this one regulates because once the amount of current that enters is regulated, it means that these parameters can also be regulated. Parameters: volume, lamp dimmer, sensing device for heat, light, humidity, force, and chemical activities. Okay, resistors are common elements of electric network and electronic circuits and are ubiquitous in electronic equipments. Practical resistors as discrete components can be composed of various compounds and forms. Resistors are also implemented within integrated circuits. I'm not going to waste much of your time here. Okay, you are going to do more of this in your JSS 3. Okay, the electrical function of a resistor is specified by its resistance, its ability to resist. Okay, electrical function of a resistor is specified by its what? Resistance. Okay, the resistance of a resistor is measured in ohms. Resistance of a resistor is measured in what? Ohms. And the symbol is this omega, this omega sign, which is Greek letter omega sign, omega letter here, or omega symbol. That symbol you are seeing there, all right, that's the symbol of resistance, or ohms rather. Okay, so that is it. This is the pictures or images of resistors. Okay, this is the images of a resistor, okay, all right. This is how with the symbols for variable. Number one, symbol for variable resistor. Number two, symbol for fixed resistor. You can see it so that whenever you see it in exam, you'll be able to say it. Now, this is how it is represented in a complete circuit. This circuit has battery, it has current, then it has three resistors there. Okay, so that is it. This is bringing us to the end of this class. We have looked at resistor as a vital component of electric circuits. We also looked at electromotive force, or the source of electromotive force, as another vital component of electric circuits. Okay, we'll say that electromotive force is the driving force of electron. That is what drives current around about your circuits. Okay, that current is flowing in your house, you can power your electric gadgets, is because of the source of electromotive force, EMF. It is measured in volts. It is measured in what? Volts. The symbol is the letter E. Okay, we have different sources of electromotive force, such as batteries, your generators, your solar energy converted to electric energy, your wind energy converted to electrical energy. We also have this of a resistor. Okay, we say that it regulates or checkmate the amount of current entering a particular component or entire circuit. We have two types of electric resistors. We have fixed resistors and we have the variable resistors. I also showed you the pictures and the diagram. Now I have a little assignment here for you. Assignment number 1: draw a simple circuit diagram showing two resistors and a source of EMF. So it is even in this our notes. You can go back and check it, or you can use your textbook to answer this question. Number 2: in your own understanding, what are the functions of resistors? Give me at least five functions of resistors. Number 3: what is the difference between resistor and resistance? It is very, very important. All right, thank you for being part of this class. Hope to see you in the next class. God bless you.